In this episode, we'll look at ASP.NET's model binding system. As you probably know, HTTP requests don't directly know anything about .NET, and the data they contain is really just a collection of strings arranged as key-value pairs. The model binding system is a powerful and convenient way to transform this incoming data into strongly typed .NET objects of your choice. In the last models episode, we used model metadata and custom templates to start creating this administrative user interface. What we didn't do though is deal with what happens when the user actually posts some data. So right now, if I enter any data, then when I post it, the form just goes blank. And the reason for that is that this form posts back to an action called create, but the create action, if we look at the source code, just simply renders the view in its default state. So of course it will always lose any data that the user entered. What we need to do then is create a new action to receive the posted data. So it will handle HTTP post requests, and it will be another action method. This time we'll say that it returns a view, and I'll give it the same name. And I will say that yes, we want to return a view. And I'm going to try and receive the data that the user posted into a job add instance. So I'll construct an instance, and then I'll manually fetch any of the posted data from the request form collection and use it to populate the properties on job add. So for example, I can get the title from request.form title. And similarly, I can populate the salary property from request form salary. What's slightly different is that this is a decimal, so I need to parse that. I can use decimal.parse, and I'll just assume that that parsing is going to succeed, because I'll be removing this code in a minute anyway. And right now, we've got a slight problem in that we've got two methods with the same signature, so I'll have to rename this method. I'll call it createPost, and then I'll use the action name method selector to map it back to the same method name, just as we did in the episode about controllers. So now when we render the view, I'll give a name to the view. I'll call it binding results, and I will pass the object that we've just parsed. So I'll need to create this view now. I'll go add view, call it binding results, and that's good. And in my view now, I will just display the data that the user entered. So for example, I can display the title, and I can display the salary, and similarly with all the other properties. Okay, so this time, if the user enters some data, and maybe a salary, and maybe a city, then when they submit the form, we can see that some of the data has been parsed out of the request.form collection, such as the title and the salary, but we didn't put any code in to parse the location, so that hasn't been parsed. So this is one way of receiving data from the user. You can manually fetch it from collections such as request.form or request.queryString, as was the common practice in web forms. But this kind of code is pretty boring to write, and also you have to keep thinking about parsing data and what happens if the data wasn't parsed properly. So ASP.NET MVC includes a facility called model binding, and that means, among other things, that you can receive arbitrarily complex custom objects as method parameters, and the framework will automatically populate them from the incoming request data. In this example then, I can add a method parameter called job add, and I no longer need this code. I can just delete that, and then I don't need to have a funny method name because it's now got a different method signature, so I don't need the action name attribute either. So everything's now very much simpler, and if I recompile and re-enter the same data, we can see that it's automatically parsed the title, the salary, location and date, and in fact all the properties have been parsed automatically from the incoming request data. And you've already seen us working with model binding several times in previous episodes already, so if an action takes any number of parameters, then the MVC framework will use its model binding system to try and find an appropriate value for that parameter. Let's now have a look at how this works behind the scenes. We've already covered in previous episodes how, when the user requests a particular URL, the MVC framework maps this first to a controller using a controller factory, and from there the controller maps the request to one of its own action methods. So by this stage in the process, the MVC framework knows what parameters are required to invoke this particular method. It gets values for these parameters using the model binding system. So for example, if the first parameter is a string called myStringParam, Then it will go asking the model binding system for a value matching the key myStringParam. Internally, the model binding system gets its data from a set of value providers, and there are 4 value providers by default that take their data from form, root data, query string, and uploaded files. The model binder asks each one of them in turn, in a particular priority order, to return a value for this key. So in this case it would first ask the form value provider, which might not return any value, then it would ask the root data provider, which might not return any value, and then it would ask the query string provider, which might have found a suitable value in the query string. So the query string value provider would return this, and the model binder would tell the framework to use this value for the parameter. The same thing might happen with the next parameter, a datetime called myDateParam. Again, it would go down the value providers, form, root data, and query string, and on query string it might get a value from query string. This time it's slightly different because we require a datetime, but yet the query string value provider can only provide strings. So the model binder has to pass this string onto a type converter, which can convert that string into a datetime instance, and then that value can be used for the method parameter. A similar thing would happen for a parameter of a complex model type such as jobadd. When the model binder knows that it needs to provide an instance of jobadd, it first uses activator.createInstance, which is a standard .NET method, to create an instance of that model type. Activator.createInstance can only call parameterless constructors, so this will only work if jobadd has a parameterless constructor. Now, assuming it does, the framework will iterate over each of the public properties and try to find a suitable value for each one. The string key that it uses to query each of the value provided is constructed by appending the property name onto the parameter name. So initially it would look for a value called jobadd.jobID, and it might go through all 4 value providers with all 4 of them saying that they can't provide any value. If this happens, then it will forget about the prefix and just take the property name. So this time it would ask all 4 of them for something called jobadd. Again, it might be that none of them will return any value, in which case it will ignore the value and move on. Next, it might move on to title, and it would start at the top of the list by asking form value provider to return a value, which might find one this time. So it would use that value for string title, and then it would proceed through all the other properties, asking all the value providers to provide values and using the first one that comes back. But how does the model binder handle properties that are themselves of complex types? For example, a jobadd might refer to another jobadd called relatedAdd. Well, if this happens, then the whole process just continues recursively. So again, the framework will iterate through all the properties on the child object and construct a key by appending the property name onto the parent property name. So it might initially look for relatedAdd.jobID and then relatedAdd.title and so on, and all of the value providers would again be asked for a value. So by the time this recursive process is completed, the framework can have produced an arbitrarily complex model object and will have used the built-in .NET type converters to parse values for any properties that were not just strings. There are various ways of customizing this process, one of which is to create your own value provider. Let's have a go at doing that now. One thing you might occasionally want to do is receive data from arbitrary HTTP headers. For example, you might want to use the referrer header to see what URL the user just came from. You can do that quite easily. You can take a value from any HTTP header just by obtaining the value from request.headers. Now, just as a way of visualizing that, I'm going to put it into view data, and then I'll display it in the view. And now if I compile and rerun the application, then when I submit the form, we get to see the URL the user just came from. Well, that's pretty straightforward, but we might wish that instead of having to fetch things from request.headers manually, we could simply declare that as a method parameter. So being optimistic, I will remove this line of code, recompile, and I'll reload to see if it still works. And we see that it doesn't, and that's because ASP.NET MVC doesn't populate method parameters using arbitrary HTTP headers by default. But if we want it to, we can create a value provider that gets data from that location. To do that, I'll create a new class in my utils folder. I'll call it HTTP headers value provider factory, and I'll make it inherit from value provider factory. And this is what ASP.NET MVC uses when it needs to create an instance of your custom value provider. So you have to override the getValueProvider method and then return an instance of iValueProvider. So I shall create my value provider class, which has to implement iValueProvider. So I'll just get Visual Studio to give me a little bit of stub code there. And of course this is going to need to access the HTTP headers, so I'll give it a private field called headers, and I'll require this as a constructor parameter. Now from my value provider factory I can return an instance of this custom value provider, populating it with controller context, HTTP context request headers. And finally, when the framework calls my value provider, I can tell it whether or not I contain a value with a given prefix, just by testing whether or not the headers collection contains a value. And when it actually asks me for the value, I can pull that out of headers. I have to return an instance of value provider result, which asks me to specify not only the actual raw value that the user provided, but also how that value was originally represented as a string, and the framework needs to use this in order to be able to recover form values after a validation failure, which we'll talk about in more detail in the next episode. So for now I'll just take that value and assume that it was a string, and if it wasn't, then we'll give it null. It also asks me what culture this value should be interpreted using. And the model binding system uses this if it needs to convert the value I've returned to some other type, because as you saw earlier, it uses type converter to do that, and the type converter will need to be given a culture so it knows how to interpret the value. Since users don't normally edit request headers directly, I think it's fairly safe to say that we can use an invariant culture for that, and if headers doesn't contain any matching value, I'll just return null. Now in order to tell the framework to use my new value provider factory, I'll add a bit of extra configuration to global.isax. I just have to say value provider factories.factories.add, and then to the list of factories I will add a new instance of HTTP headers value provider factory. And as you remember, these value provider factories are in a particular priority order, so if I wanted to add mine at the top of the list, making it the most highly prioritized, I could use the insert method to insert right at the top, but I don't really. I'm quite happy for it to go at the bottom of the list, so I'll just use add. Now with all that in place, I'll try reloading this page. This time, as you can see, the referrer header has been passed to my action method, and my action method didn't need to know anything about where that data came from, it just accepts matching values from any value provider. And this technique is not limited to receiving strings. Your value provider can return arbitrary object types, which can be helpful if you want to return objects from session or from an IOC container. One further tip before we move on: if you're creating a value provider that really just wraps a name value collection, you don't actually have to implement your own value provider at all. So I can actually delete all of this code and instead use the built-in name value collection value provider, passing it the headers collection as a parameter. I do have to still give it a culture, for which I'll use a variant culture again. Now if I recompile and reload, it still works. Now if you want to customize the model binding system even further, and you want to go beyond simply providing extra values through a value provider, then you can hook in right to the guts of the model binding system by creating your own custom model binder. I'll show an example that works with dates. As you can see, we can already enter a valid date, and when I submit the form, the model binding system parses the string that I've entered as a .NET datetime instance. But what if I want to allow users to enter things like this? Now if I try to submit that as a datetime, the model binding system won't be able to parse that as a datetime, so it will simply use this default value instead. In the next episode we'll look at validation and how you can block bad input and display suitable error messages. But for now, I want to accept the string tomorrow as a valid entry and parse it sensibly. I can do that using a custom model binder. And I don't have to edit my controller code at all. I'll create a new class, again in my utils folder, and call it Natural Dates Model Binder. Like all model binders, it has to implement iModelBinder, which means that it needs to implement this method bindModel. and I'll just tidy this up a little so that you can see what's going on. Now the process for implementing a custom model binder is slightly more complex, but it's not actually that bad. There's just a few steps that we have to go through. So the first step is to decide whether or not we're actually going to supply any value back to the system. Because if there isn't any data, we want to bail out early and let the framework use some other method to try and supply value. The binding context property specifies a whole bunch of information about what's happening with the model binder at the moment. An important property is model name, and that will give us the fully qualified name that the binding system is currently trying to resolve. I can also use binding context to ask the framework to go through all the value providers in priority order and ask each of them for a value matching this key. Now, if none of them returned any result, or the only value we got back was something blank, then we'll just cancel the process early by returning null. So if our method is still running, it obviously did get some value, but that doesn't mean it's necessarily something that we can parse. The incoming value might still cause a validation error, and if it does, we want to be able to redisplay the form and preserve the value that the user entered. Now you won't quite understand this bit at the moment until we get onto the next episode that talks about validation in detail, but for now I'll just show you what we have to do. Model state is a temporary storage area that we can use to store information about the model that the user is currently working on. And if we call setModelValue, we can preserve the incoming value in case we have to display it as part of a validation error. However, this episode's not about validation, so that's the last I'll be mentioning of that. What does matter for this episode is that we're going to try and parse the incoming data. Now I'm going to assume that the incoming data will have come from query string value provider or from form value provider, which I happen to know always return their data as string arrays. So I'll get the incoming raw value and pick out the first entry, which will be the value that the user has entered. Now I have to decide whether or not I can parse it. I'm going to use an open source date parsing library that I got from Codeplex called Datetime English Parser that can handle strings like tomorrow or next Wednesday. First I have to decide whether it will successfully be able to parse the text. I'll implement this method in a minute. Now assuming that it can parse the text, I'll ask it to do so. And I have to give it the current time so that it can handle relative times such as tomorrow. And if it can't parse the text, I'm going to register a validation error, which again is not something we're really going to talk about during this episode. We will talk more about validation in the next episode. Finally, I have to implement this canParseText method. And unfortunately the open source date parsing library that I'm using doesn't give me any easy way of telling whether or not it can actually parse some text, so I'm using a slightly hacky technique to do this. We won't worry about how that works because it's not really got anything to do with model binding. When you're implementing your own model binder, you can use your own logic to decide whether or not a certain piece of text is parsable. Now with all that in place, I have to tell the MVC framework to use my new custom model binder. And I'm going to show you 3 different ways of doing that, which have got their own strengths and weaknesses. The first of which is very simple. It's just the same as how we registered the custom value provider. I'll say modelbinders.binders.add, and then I'll tell it what type this binder should be used for. So it should be used whenever we're binding a datetime property or object. And the binder, of course, is the natural dates model binder that we just created. Now all being well, I can rerun my application and enter a date like tomorrow, and our custom model binder will kick in and correctly return the date that corresponds to tomorrow. And I can also do things like next Friday. And it will use its knowledge of the English language to parse that as a date time appropriately. It also means I can enter dates like 3rd of October, and that will be handled correctly as well. And my controller doesn't need to know anything about this because it's all internal to the model binding system. There are at least 2 other ways of telling the framework which model binder you want to use, so we could in fact remove this registration and apply it in a different way. One way works well if you're applying a binder for a custom type is to use a model binder attribute on that type itself. So if I owned the source code to datetime, and by the way I don't, then I could use a model binder attribute directly on it. And now the framework would automatically detect this and use my custom binder whenever it wanted a datetime. But I don't actually control the source code to datetime, so that isn't going to work for me in this case. The other approach is to specify a binder on a per parameter basis. So inside admin controller, if my method took a parameter of type datetime, then I could use the model binder attribute on that particular parameter. So you've got two different ways of registering a binder globally against a type, and one way of registering a binder against a particular action method parameter. And of course it's up to you to choose which fits in best with your requirements. One way you can control model binding is to tell it which properties to bind and which properties to ignore. As an example of when you'd need to do that, imagine that our job_add class has a further property called featureOnHomepage, and this is a special important property that only certain types of administrators are supposed to be able to control. I'll just add some code to the view to display its value. Now when I recompile and submit the form, because we didn't supply any user interface for the user to enter some value for featureOnHomepage, it returns its default value of false. But just because there's no user interface, that doesn't stop the user from supplying some value. As you learned earlier, the model binding system gets its values from form, from query string, routing, and potentially other places, so a savvy user could simply add a new query string parameter, featureOnHomepage equals true. Then when they submit some data, we'll see that their chosen featureOnHomepage value has been respected. That's not what we want. We don't want them to be able to control arbitrary properties. To prevent this, you can use the bind attribute. When you're binding a certain parameter, you can say exclude, and then give a comma-separated list of the properties to exclude from binding. Now if that user tries the same trick again, we'll see that the title still gets bound, but featureOnHomepage does not. Alternatively, you can use a whitelist by saying include equals, and then we could say we only want to bind the title, for example. So now if the user enters a title and a location, and a featureOnHomepage query string value, then the title gets bound, but location and featureOnHomepage does not, because they're not included in the whitelist. You might want to have a way of configuring globally that whenever anybody binds a job ad, it should exclude the featureOnHomepage property. Instead of declaring the bind attribute on the action method parameter, you can declare it directly on the model property itself. So I can say directly on the job ad, exclude featureOnHomepage. Now if I compile and resubmit a form, I've still got this dodgy query string value, but it will be excluded from binding even though everything else is included. And because this rule was declared on the model object itself, it can't be overridden on any action method parameter, so there's no way of accidentally binding to that property. So far, I've only shown you how to use model binding when you're receiving objects as action method parameters. But sometimes you don't want to receive objects as method parameters because you want to use your own logic to instantiate them, or maybe fetch them from a database or something, but yet you still need to update them according to the data that the user's just entered. Well, that's okay, because you can invert model binding manually. Here's how to do it. First, let's assume that we don't want to take job_add as a method parameter anymore, but we want to just declare it as a local variable. And we'll use our own logic for instantiating it. Now we need a way of invoking model binding against this object that we just created. That's pretty easy. We just use a method on the controller base class called updateModel. Now I'll compile and I'll rerun. If I submit some data, we'll see that the model binding took effect, even though we didn't receive that object as an action method parameter. One aspect of the behavior is slightly different now though, because if the model binder can't parse one of the fields, for example if I enter an invalid decimal, then it will throw an exception saying that it couldn't actually update my model. The way to deal with that is either to catch the invalid operation exception, or instead of calling updateModel, call tryUpdateModel, which returns a boolean value to say whether or not it succeeded. So I could say if it failed, then I'll implement some logic that deals with that. But I don't have to do anything if I don't want. I can just accept that the binding was only partially successful. So this time I'll recompile and resubmit the same request. and we'll find that we got a partial binding success, so title was parsed, but salary was not. When you call update model or try update model, you can pass extra parameters to say which value provider should be used or which properties should be included or excluded. You've seen how the model binding system works recursively to populate an arbitrary object graph. But what if the object graph contains a set of repeated elements such as an array or a list? To populate one of these, your incoming data needs to follow a particular naming convention. Here's an example of how you can do it. Here we've got two blocks of input controls that refer to different job ad instances. Notice that the first block all have names with a 0 index, and the second block all have names with a 1 index. When the model binding system receives this data, it will recognize these 0-based sequential indexes and automatically return either an array or a list of job ad instances. So your action method can simply declare that it receives one of those, and the framework will supply a suitable instance. Now, in case that looks like a lot of manual work, I should point out that the built-in html.editor4 helper, if you pass it an array or a list, will automatically produce a series of input controls following this naming convention. So that's fairly straightforward, but sometimes you might not want to have sequential 0-based indexes. It might be more convenient to use some kind of unique primary key as the index, or possibly even a random GUID for each item. This could be more convenient if you're dynamically adding or removing items on the client, and don't want to worry about keeping the indexes sequential. In that case, you can use an alternative naming format that I'll show an example of here. I've highlighted the differences. Notice that instead of using 0, 1 and so on as the indexes, we can now use arbitrary strings. But for each entry in the collection, you have to provide a hint to the model binding system so that it recognises your index. Your hint fields all need to be named index. The MVC framework doesn't care about what index values you use as long as they're unique for each group. So this collection of input controls would be bound in exactly the same way to a list or an array of job ad instances. It's beyond the scope of this episode, but if you want to see how you can use this technique to create a dynamic list editor where the user can add and remove entries on the client, I've created a blog post at tinyurl.com/mvclist. And that's enough information about model binding. In the next episode, we'll move on to see how you can combine metadata and model binding to implement validation, rejecting bad values and displaying suitable error messages.